Good afternoon, everyone. Welcome to the Advanced RI-CTR Survey Design Pearls and Pitfalls seminar. Today's speaker is Dr. Melissa Clark, a professor in the Departments of Health Services Policy and Practice and Obstetrics and Gynecology, as well as the director of the Survey Qualitative and Applied Data Research Corps, otherwise known as SQUAD. We want to welcome everyone for Melissa's seminar. If you have any questions, feel free to put them into the chat, and Melissa will be able to answer them towards the end of the seminar. Go ahead, Melissa.
Thank you, Amy. Hello, everyone, and thanks for joining us. I'm happy to be here, and a good day for me is any day that I get to talk about survey design. So I appreciate the opportunity, and I hope that you'll enjoy this session. So survey design is a big topic. So in thinking about how to frame this 1 hour we have together, I've tried to set the content of this presentation at an advanced beginner to intermediate level. I'm going to go beyond how do I write a survey to how do I ensure the data are valid. So many people that think that doing a survey is easy, and I hope that by the end of this session, you'll come away being able to answer the question of why good enough is not enough when it comes to survey design. So the topics I'm going to focus on today are very quickly some terminology so that we're all using the same terms. I'm then going to focus on survey quality. And here I'm going to focus on two aspects of survey quality. That is with regard to representation. And here we'll talk about sampling and sampling frameworks. And then second, the part about measurement. And there I'll focus on some topics around instrument construction. So let's start with terminology. So in terms of the common survey design terminology, the word that is probably the most misused in the literature is actually the word survey. So what survey means to survey methodologists, and what we hope that it means to everyone else, is that the survey is the process of collecting the data. It is the entire process of doing so. The questionnaire is the data collection form, whether or not that's on paper or that's by computer, whether or not it's self-administered, interviewer administered, that's the data capture form. Instrument is another name for questionnaire. And then when we talk about what goes into that data collection form or that questionnaire, we first want to think about what's referred to as constructs, domains, or variables. Those are the things we want to measure. When we use the word scale or measure, those are the items that are used in combination with each other to measure those constructs, domains, or variables. And then the items are the individual questions that we ask respondents to answer. So I'm going to use throughout this session an example. And I tried to think of something that would be relevant to both medicine and public health and folks across the campus. And so I thought I would take the topic of AI mental health and chatbot use. And I'm going to use respondents. The respondents that I'm going to use throughout are college students. So in that terminology, our outcome or our domain would be depression. The scale that we might use is the CESD, the Center for Epidemiologic Studies Depression module. A specific item on that scale, that CESD, is an example like during the past week, I felt everything I did was an effort, with a response scale or a response set of rarely or none of the time to most or all of the time. Another domain would be the exposure. That would be the use of a chatbot. An item we might ask is how frequently they use such thing. Another domain would be the sociodemographic characteristics we want to know, those being measured by items like year in school, concentration, gender, first generation status, etc. So that contextualizes now how I'm going to use these words throughout the rest of this presentation. So let's start with a broad overview of survey quality. So when we're doing a survey, we're ultimately doing so to be able to generate some type of survey statistics for our population of interest. We want to make inferences to a population. So when we are thinking about survey quality, there are a number of places where error is possible. So much of the time, the focus is on the measurement side. But there are just as many ways in which the representation affects the accuracy of the survey statistics. So today, I'm going to spend time on both sides of this diagram, both talking about how to improve survey quality from a representational perspective as well as a measurement perspective. So let's start with the representation side. So the first type of error with regard to representation is what's referred to as coverage error. So that's the error that results from a difference between your intended target population and the sampling frame members. In other words, who are those individuals on your list of folks that from which you're going to sample from? That's what's referred to as a sampling frame. So let's say that our target population, for our example, is full-time undergraduate students at Brown University. This is who you want to be in the covered population. That is your target population. If your sampling frame only includes first and second year students, that would be an example of undercoverage because the target population included students of all years. On the other hand, if the sampling frame includes graduate students, that would be an example of overcoverage because, again, your target population, your intended population for whom you wanted to generalize, were undergraduate students at Brown. Another type of representational error is what's referred to as sampling error. And that's the error that results from a difference between the sampling frame members, in other words, who's on your list to sample from, and who's actually in the sample. So for my example about a survey of undergraduate students, an example of sampling error would be if you only included students enrolled in courses of more than 100 students, so the large classes. And you do so because they are easier to access. You can talk to those professors, lots of students in those classes, you could get a sample. They would be on the sampling frame because they are members of the Brown University undergraduate enrollment, but that is your sample now is only those in large classes. That's an example of a convenience sample. So the sample that's enrolled in those larger courses may be quite different from those enrolled in smaller courses. There may be differences by year in school with those in large courses, maybe the first and second year students, as well as the types of concentrations in which they are enrolled. There are some concentrations that have a lot more students. You're going to have much bigger class sizes. The difference in who all was on that list of Brown University enrolled students versus who you sample from is an example of a sampling error, unless the sample is representative of that entire population. Okay, a bit more about sampling. So all of us would question the results of a survey in which we were told that the only individuals who participated in a survey about proposed legislation to add bike lanes to downtown Providence streets were those who were recruited while biking on the bike paths, right? We would say, that's not a good sample. You only talk to people who bike. We'd also question the results of a survey about physical activity among older adults if we only talk to people while they were walking for exercise in the mall. Right? We'd say the same thing. That's a biased sample. So these are examples of convenience or non-probability-based samples. and we would certainly question the results of those studies. However, many surveys in medicine and public health also use these types of samples. For example, almost all surveys in which individuals are recruited online are convenience or non-probability-based samples. There are some exceptions, but in general, most online surveys come from a convenience sample. So what that means is individuals do not have a known probability of being selected, and therefore we have no way to account appropriately for their representation in the population of interest. So, as much as possible, we want to be using probability-based sampling methods where each individual has a known non-zero chance of being included in the sample. So as an example, let's say we have a population of 12 individuals and we want 4 individuals in our sample. Probability-based approaches would be, and again, the 3 most common would be, first, simple random sampling. Here we'd assign a unique number to each member of the population from 1 to 12, and then we'd randomly select 4 numbers. The individuals representing those 4 numbers would be in our sample. So it's referred to as a simple random sample. Another probability-based sample would be to randomly our list of population members. So we take those 12 population members, we'd randomly order them in a list, then we'd randomly select a number from 1 to 3, and we'd select every 3rd member for a total of 4 in our sample. And finally, the 3rd common probability-based sample is what's referred to as stratified sampling. Here, we place the members of the populations of interest into groups with informative characteristics. In this case, we might say something like year in school, concentration, whatever are meaningful characteristics that we want to ensure representation of. We would put those into those strata, and then we would randomly select individuals from those strata to ensure that there is representation of individuals from each strata. So there's lots more that we could talk about with regard to sampling, and I'd certainly be happy to talk about that at another session. But keep that in mind as we continue to talk about representation, because the way we sample is important for the kinds of conclusions that we can draw based on the inferences that we calculate. Okay. So another type of representation error is what's referred to as a non-response error. And there's the error due to the systematic difference between those who respond and those who do not respond to your survey. So non-response error is demonstrated by the 2 figures on the right in this slide. So in survey A, 1,500 randomly selected individuals from a population of 2,000 are invited to participate, and out of those 1,500, 100 responded to the survey. So that's a response rate of 6.7%. In survey B, 200 were randomly selected, invited to participate, and 100 responded for a response rate of 50%. So in both cases, you had a final sample size of 100, but survey B is less subject to non-response error due to the higher response rate. So the intention here is to try to increase our response rates in order to reduce non-response error. Okay, so response and cooperation rates are 2 areas that I see most misrepresented in the literature. And so they are often used interchangeably when they do not mean the same thing. So I'm just going to take a couple of minutes here and show you the differences and show how different they are in terms of their calculations. So response rates are the number of eligible sample who complete the questionnaire divided by the total number of eligible sample. Cooperation rates are the number of eligible sample who complete the questionnaire, divided by the total number of eligible sample who could be contacted. And that is the big difference. So let's go back to our study of full-time Brown undergraduate students about social media use and mental health. And let's say we randomly select 1,000 of those students and we send invitations to them. We learn that 50 are ineligible because they're studying abroad or they're on leave. And then there's another 40 for whom it's unclear about their status at the university. So we're unsure if they're eligible or not. In other words, we're not clear if the email invitation would have even reached them or not. So we have a group of these individuals, these 40, that we don't know their eligibility status. So one thing we can do is to assume that the ineligible portion that we don't reach is the same as the ineligible portion that we reach. So we have 960 individuals in this sample that we know their eligibility. That's the 1,000 minus those 40 that we don't know about their eligibility. If we say the 50 that we are known ineligible divided by those 960, that gives us an ineligibility rate of 5%. If we apply that 5% to those 40 people that we don't know about, we can estimate that there's an additional 2 individuals out of those 40 that are ineligible. So with that information now, in determining the number of eligible for the denominator of our response rate calculation, we can assume that all of the unknowns are eligible and use the more conservative estimate of 950 as our denominator. Or an equally valid approach to do is we can assume that an additional 2 of the unknowns are ineligible, and we can remove them from the denominator as well. That is referred to as a less conservative approach to the response rate calculation. And then we have all of those who do not complete. So in this sample, there's 200 that refused. There's another 50 that did not finish the questionnaire. And then we have 150 for which we never heard from them. We know that they're eligible. We know that they're enrolled at Brown, but we just have never heard from them. They just have no response. So in total, we have 550 completed questionnaires. So our response rate is 57.9% if we use the more conservative approach, or 58% if we go with the less conservative approach. Now, cooperation rates are comparably calculated, but the denominator is those who can be reached. So in this example, you would remove those 150 who were never available and from whom you have no information from the denominator. Again, either using the more or less conservative approach for how you handle ineligibles. So this results in a cooperation rate of 68.7 if you go with the more conservative approach, or 68.9% if you go with the less conservative approach. And unfortunately, in trying to show higher response rates, researchers often incorrectly report cooperation rates as their response rates, therefore incorrectly inflating their response rates. The good news is that the professional organization, the American Association of Public Opinion Research, which is my professional organization, has a response rate calculator in which all you have to do is put in the relevant information into the calculator. There's both an online version and an Excel version, and the response and cooperation rates are calculated correctly, and then you can report on them based on the APOR standards. I want to do a second example to just demonstrate the difference between the relationship between the response rate and the non-response bias. So let's say we're back to our Brown University students, and we have we're doing a pilot study, and we have 50 students in the population of interest. First-year students there's 25 first-year students represented by the purple color in that population of 50. There's 15 second-year students represented by the pink for a 30% representation in the population of interest. And there's 10 students that are third-year students representing 20% of the population. So if we wanted to sample 12 individuals, we would want to select the groups proportional to their distributions in the population. So we would sample 7 from the first years, 3 from the second years, and 2 from the third years. So then we've distributed the survey. We get the questionnaires back. Those with the X on them means they did not participate. Those without the X means that they participated. So when we look at our response rate, overall, we did pretty well. We got 50% of the students to participate. But we have differential response rates by strata. So we have 57% of the first years, 66% of the second years, and 0% of the third years. So we have a non-response bias in that we have underrepresented the third-year students and overrepresented the first and second-year students. Now, again, you probably say, well, that just happens, and what can we do about it? And the point is that if you sample using probability-based sampling methods, you can adjust for these kinds of non-response errors in your analyses because you know the population of interest distribution. And therefore, we can do what's referred to as post-stratification weighting and other types of weighting that can account for the non-response bias. It is often doesn't completely correct for it, but certainly makes the statistics more reliable, more valid, because they are being represented by the population characteristics. Okay, so those were my first questions about representation. So now I'm going to move on to the measurement aspects of survey quality. And so when thinking about measurement, one consideration is the mode of data collection. So this is the decisions between paper versus computer-assisted surveys, either self-administered or interview-administered, and then interview-administered either by phone or in person. So when considering which data collection method provides the highest quality data, we have to consider both the question complexity and the question sensitivity. So by question sensitivity, I mean, how uncomfortable are individuals going to feel when they're answering the questions? In other words, how much does this make them feel like, oh, if I answer a particular way, I may be judged, I'm myself or a member of the communities I belong to may be judged a particular way. That's what I mean by question sensitivity. So surveys of sensitive topics are always best done self-administered. Whether it should be by paper or computer depends on the complexity of the instrument. So instruments with branching logic that requires a lot of skip patterns, such as what you learned last week with Chris, should be done by computer as much as possible within the logistical and resource constraints that you have. In some cases, there are logistical reasons why they need to be done on paper. If you have a very complex survey, you're going to need to figure out if it needs to be done on paper, how to reduce that complexity, or you're going to have a lot of missing data, a lot of problems with data quality. because it's generally just difficult for all of us with complex surveys to follow all the logic on paper. All right, so I know last week you learned a lot about REDCap, and I am not the expert like Chris is, but I hope you got lots of useful information from Chris about REDCap. I only wanted to spend 1 minute distinguishing between the strengths of REDCap and the strengths of Qualtrics for survey research. Both have a lot of strengths, both have limitations. And I think it's useful to at least know, I decided to pick the top 4 strengths from both programs. So, as Chris probably discussed in some detail, if you need to track the same person over time with different types of events, like you're linking surveys with lab tests, provider visits, REDCap is built for that structure. That is not, longitudinal studies is not the strengths of Qualtrics. REDCap also has very strong data integrity and audit trails. So that tracks every single change made to a data point, who changed it and when. And this is often required for high-level clinical trials, particularly for the FDA and other government sources. Another strength of REDCap is that it has very seamless exports in terms of going from REDCap to R, SAS, data, and SPSS. That is also possible in Qualtrics. It is not as seamless. And finally, REDCap has a very robust mobile app that allows for data collection in the field without an internet connection. Again, Qualtrics has that capability too. It is not as robust as REDCap. The strengths of Qualtrics is that it has very advanced logic capabilities. It can do very complex branching. It can do very complex randomization. It can do what's referred to as looping, where you're asking the same set of questions for multiple items, such as if you want to know things, you have a series of medications and you want to know a series of questions about each of those medications. REDCap is going to be very much easier to use than REDCap for that. Probably the biggest strength of Qualtrics is that it has a very strong user experience. It is much more modern and intuitive looking. So respondents are less likely to drop out of surveys because the interface looks modern. It's very mobile optimized. You can do a lot of what we refer to as bells and whistles. You can add pictures, very sort of, I don't know, I don't want to use it as a negative term, but very slick in its look and feel. Qualtrics does have built-in analytics that folks can find helpful. Those are built-in dashboards that you can use as analytic monitoring tools without having to export the data. And finally, it has excellent tools for email distributions. So tracking who is the survey has been sent to, who has responded, and you can also set up automated reminders and automated email distributions. So again, I'm not saying one is better than the other. Most of us have the tool we like better than the other. They both have a lot of strengths, and it's really dependent on what the intended use is. Okay, moving on to other things about measurement. So that's the organization of the instrument, and this is probably, I don't know if it equals the number of times that I see problems in surveys relative to the response rate calculations, but probably pretty close, is how the instrument is organized. So there are many randomized trials done by folks like me where we test the question order. What gives us the highest response rates? What gives us the most valid data if we can compare it to other data? What allows folks to go through the survey the quickest with the most accuracy? Answering those types of questions consistently over time, regardless of the topic being asked about, regardless of the population, regardless of the data collection mode, this is the order that results in the highest quality data. So the introduction, what is the study about? Any kind of the consent process, followed by the questions that are needed to determine eligibility, and only those questions. Followed by the substantive questions. After the substantive questions, then the background and demographic questions, and then any kind of follow-up post-assessment questions. So in our example of our Brown undergraduate students' willingness to participate in an AI mental health chatbot, in a survey on that topic, we'd start with the study overview and the consent information. We would then ask the questions about their status. Are they enrolled full-time? What year are they in school? We would then ask the questions about the chatbot and other social media use. We would then ask the questions about the depression items of interest. We would then, only after getting through all the substantive questions, ask those demographic and background questions, such as their concentration, their gender, or first-generation status. And then the final question would be something like anything else important that we haven't asked about. Now, many folks say, yes, but I get many surveys in which the demographic questions are first. And my response to that is not best practice. And the reason that is because those kind of questions, the questions about our identities, the questions about the most personal things about us, are always the most sensitive. Putting them first does two things. One, it often makes people stop participating because they fear how they're going to be perceived. They are concerned about what questions may follow. They don't know what's being asked of them. It makes them uncomfortable, so they're going to stop. Or they say, I feel like I should answer in a particular way so that I or members of the communities I identify with don't look bad. And finally, if you put them at the end, a positive is that if individuals choose not to answer those questions, you still have all the questions of most importance to you, your substantive topics. You have data on that. So you can do a lot of your analysis, even if you don't have those identity types of questions. And then finally, I'll say that within those substantive questions, you want to also order by sensitivity, in that you want to put the most sensitive questions towards the end. The reason there is you want folks to become comfortable with the topics you're talking about what you're asking of them, and you want to give them a chance to get settled into what is this about before you ask the most sensitive questions. Again, those demographic questions will always be the most sensitive on almost every topic. So they would come after something like the depression questions. And a topic like this, where we know that younger folks are fairly comfortable talking about their social media use, less comfortable with answering questions about their mental health, we would put the social media use questions before we would put the mental health questions. Okay, so in deciding question items to include in the survey, the first question we have to ask is using items from other studies always preferable to modifying or creating new ones? So here's an example of a question. How much of the time in the past 4 weeks have you felt downhearted and blue? From all of the time to none of the time. So if we look at this item, we might say, it's not very common that I hear someone talking about feeling downhearted. Not a thing that's particularly commonly heard by most individuals. Many folks, and particularly those for whom English is not a first language, find the use of the word blue peculiar in this sentence. Also, many respondents will say that they don't know the difference between some of the response options. They'll often ask, what's the difference between a good bit of the time and some of the time? So I just pointed out 4 things that make this question have some concerns about it. And yet, this is one of the items from the most commonly used quality of life questionnaire in the world. It's from the SF-36. And so this has been used with hundreds, thousands, we're probably close to millions of people by now. And so this would be an example where you'd have to make a decision about, depending on your population, depending on what your intention is, you might say, I want to compare my findings to the other studies that have used the SF-36. I recognize the limitations. I am still going to use this question. So it's always preferable to use already validated instruments if they are relevant to your research question and relevant to the populations of interest. But bad questions produce bad data. So sometimes modifying or creating new ones will be your better strategy. And that is one of the hardest things to decide what you're going to do after you've done all your literature searching, you've determined potential questions, is to decide, am I going to use already validated ones, even though there's concerns about them for X, Y, and Z reasons, or am I going to say those are not going to work and I'm going to modify them, or I'm going to create new ones? Okay, so I'm going to take a pause and ask you all a question and have you put your answer in the chat. For surveys of the general population, questions should be written at what reading level? Would you say less than 4th grade, 4th to 6th grade, 8th to 9th grade, or 11th to 12th grade? What do you think? You can put your answer in the chat. All right, I'm getting a lot of good answers. Okay, how about this question? For surveys of professionals, what level should we write the questions at? Doesn't matter, 4th to 6th, 8th to 9th, or 11th to 12th. All right. So the answers is B for both. So for general population surveys, 4th to 6th grade is the functional reading level that makes it accessible to the majority of the general population. We certainly always it would be ideal if we could get it even less than that to make it accessible to almost all. Though that's quite hard to do, and particularly in a lot of the medical and population-based surveys. But we want as much as possible to get to that 4th to 6th grade. Now, 4th to 6th grade is also the level that we write for professionals. And that is not because those of us who professionals haven't been to school for a bazillion years, or that we necessarily read at a functional level of 4th to 6th, but that really has to do with attention. So if you just consider yourself and think about the last time that you completed a survey, regardless of the mode, and think about what else you were doing at the time. If we were all honest with ourselves, most of us would say we were probably multitasking. We might have been driving home from work if it was some interview administered. It might be we were waiting for the water to boil, cooking dinner, and answering something on our mobile phone. It might be that we were kind of burnt out of doing our notes at the end of the day, so we hopped over, did the survey before getting back into our electronic medical record, right? So it's the attentional issues that is really for professionals. And what best practice has found is that if we write them again at 4th to 6th grade, as best for the majority of the questions, people can do that multitasking and still give high quality data and high quality answers. So again, regardless, try to get it at that 4th to 6th grade reading level. The easiest way to test that is just in Word under the readability statistics. Increasingly, we'll find that AI can do this as well, checking the grade level, but right now, the simple word function works best unless you want to pay for one of the grammar and readability statistics packages. Okay, so let's focus a few minutes on what I'm going to refer to as the psychology of human respondents and how we as humans react as respondents. So let's take a question like this. On average, about how many hours of actual sleep do you get per night? Most of us know that more hours of sleep is better than fewer hours. So as written, with 8 hours first and less than 5 hours last, this will usually lead to what's referred to as social desirability bias. That means giving the answer that is believed will be viewed favorably by others. So what that results in then in our analysis is that there would be an overestimate of the number of hours of sleep received. So to address this bias of over-reporting good behaviors and under-reporting bad or socially discouraged behaviors, the best practice is to put that least socially desirable response first. So in this case, given that more sleep in general is what's the recommended, we would start with the category that has the least number of hours of sleep. So we would reverse those categories. Okay, another consideration is how respondents see or hear the questions and what they focus on when they hear or see them. So we have the problem of individuals picking the first response. That's what's referred to as a primacy effect, or the last option, which is what was referred to as a recency effect. Here, think about the fact that we in general as humans are a little bit lazy in what we attend to. So to address these types of effects for categorical variables, there's a few solutions that we can do. If we're using a computerized instrument, we can randomly order the response options so that they come up in different orders for different participants, and we don't end up, for instance, with YouTube being always picked first, Snapchat always being picked last, or vice versa, because participants are seeing different things. And so it's more likely that we will get the distribution that's representative of the population. Alternatively, and an approach that can be used for paper-based and computerized assessments is just to alphabetize the categories, regardless of the data collection mode. All right, so that's primacy and recency bias. So next is consideration for the behaviors that I put in the category of lazy, inattentive, or devious humans. So these are the first 4 questions of the CESD, that depression scale. So one of the first things we always want to look out for in question tables such as these, where we have a number of items with the same response options, regardless if it's done on paper or computer, is what's referred to as straight lining. And that is answering all of the questions with the exact same response options. Now, in some cases, that the response options, the person would naturally pick the same response options, but that is very uncommon with questions that have more than 2 or 3 in a table such as these. So that's what's referred to as straight lining. We also have to look for patterns such as these. This is where people or respondents make pictures or they do random clicking. So I don't know if you can tell, depending on how big your screen is, the picture drawn here is actually of a check mark. So there's check marks within a check marked pattern. If I gave you plenty of time to look at the items and look at the response options, you would notice that these don't make logical sense. Given how they answered one item, they shouldn't have answered another item in the way they did. So this is definitely evidence of making pictures or random clicking. So as problems of bots, fraudulent responders, and inattentive humans continue to explode in survey research, and particularly for online types of data collection, we increasingly need to build in approaches to try to combat that, or at least to detect it, so that we can determine that respondents that are such inattentive humans or not humans at all are not included in the final data set. We can do things like instructional manipulation checks. So here, as I've shown in red, we give some types of instructions to do something that bots, those are the non-humans, would be not able to detect. And the inattentive or fraudulent responders would likely do incorrectly or not at all, because they're not paying enough attention to do what we ask them to do. So you put these attention checks or manipulation, they're sometimes called manipulation checks, throughout in order to try to detect if that's the behavior that's happening in your survey. I'd also like to spend a couple of minutes on what I will call beyond the Likert scale. So Likert scales have been used for years and were developed in the 1930s. They were initially primarily tested amongst psychology students, who at the time that these were first developed were primarily male, white, and well-resourced. They are still commonly used response scales in survey research. However, there's an increasing recognition of their limitations, particularly as we've done a better job as the research community in including more representation and better representation in our studies. So what we've learned is that these kinds of questions are quite cognitively complex. So we often see breakoffs in a survey when we get to these types of questions because folks say, oh, that makes my head hurt, or that's too complicated, I'm going to stop here. So in an online survey, if you come to these kind of scales, you'll often see large numbers of breakoffs. We also can get what's referred to as acquiescence bias, and that's a tendency towards agreement, regardless of the question content. That also generally comes because the questions are cognitively complex, and people just say it's just easier to just agree with it. There's also a bias related to education in that those with less education tend to agree more with the statements, even if that is not their true answer, than those with more education. We've also got the problem of this term strongly. That suggests an emotional component to the question. And oftentimes we don't intend there to be an emotion associated with the question. It often is something that has to do with a behavior or a knowledge or a cognitive process. And so what is increasingly happening are people are changing it from strongly to completely. This does not totally solve the problem, but has shown evidence that there is more accuracy, again, when we have a gold standard to compare to, when you use completely rather than strongly. And finally, we have to deal with this question of whether or not we're going to use a middle category. Very much depends upon what you intend to, how you intend to use the scale, and whether or not the neutral category has been used in other studies in which the scale is being compared. But in general, in a lot of topics in medicine and public health, we don't want the neutral category because we want folks to put themselves on either the agree or disagree side, because we're trying to develop interventions, we're trying to test an outcome. So having that neutral category often ends up with a lot of folks picking that. So a lot of straight lining, but also less variability in the data than we would have if we removed that neutral category and forced us agree or disagree response. Now, there are some alternatives that can be used rather than the Likert scales. These are just two examples of the same types of items that were on that Likert scale, response scale. But in this case, we're saying how anxious did they feel, from not at all to very anxious, and how much did social media make them feel connected to their peers, from not at all to very much. These are more behavioral types of questions. You find more variability when the questions are asked this way than the same content asked as a Likert scale. Another approach to something other than the agree-disagree scale is what's referred to as max diff or worst-best scaling. Here we say something like, consider your social media habits over the past 30 days and consider the following 4 experiences. Select the one that describes you the most and select the one that describes you the least. And so then respondents would pick one item that says the least like me and the item that says most like me. Again, gives you more variability, less break-offs, addresses the number of concerns with the Likert scales. Not all items can be formatted to this type of approach, but certainly something to consider. Okay, so in designing any survey, unless all of the questions have previously been used in your population of interest, it's important to test the items using cognitive-based interviewing, which is also referred to as cognitive testing. So the goals of cognitive-based interviewing are first to identify errors in the interpretation between what the researcher intended and what the respondent understood. And the second goal is to test the response process in terms of, does the respondent understand the words being used? Can they actually remember the information? Can they fit their experience into one of the provided categories? And finally, is the answer they want to give actually available? So cognitive-based interviewing is done, it is a qualitative approach. It is done to test survey items. So let's take an example such as this. Please indicate how much you agree or disagree with the following statement. I feel anxious when I cannot check notifications. Strongly agree to strongly disagree. That's the item we're intending to put on our questionnaire. There are 2 common types of approaches or techniques used in cognitive interviewing. One is what is referred to think alouds. So we ask respondents to talk out loud about what they're thinking as they answer the question and pick a response. So in this case, a respondent might say, I'm thinking about the word anxious. I'm thinking, well, I don't feel scared anxious, just annoyed anxious. So I'll pick neutral because agreed feels too strong. The other technique is called verbal probing. So again, we would ask the question we are testing. We would ask the respondent to give us a response, and then we would follow up with a series of probes about the question and the response options. So we might ask the question, the respondent gives us the answer neutral. Our follow-ups would be, what did the word notification mean to you? Were you thinking of the emails or just social media pings? So typically, both think alouds and verbal probing techniques are used throughout a cognitive interview, depending on what questions are being tested and what the concerns about the questions are, and what concerns you have about the response options. So I'll conclude my remarks with 2 additional things. The first is that you should always plan for and conduct a pilot test of your survey using your intended sampling approach and instrument. Don't forget to put that in your IRB application so that you can do the pilot test. So many people come back to me and say, Melissa, it'll take me too much time, or we really need to get into the field. And I always answer back, I've never seen a pilot test to be a waste of time. The quality of the survey has always been better. So I would highly encourage you to always do a pilot test, even if it's a small one. And second, I'd always recommend starting with what's referred to as a soft launch. And what that means is releasing your survey to a tiny fraction of your total sample. That can be somewhere on the level of 5 to 7, maybe 10% of the sample. This is particularly important for online surveys because if you have any problems, you can always pause, fix those issues, and then release the survey to the full intended sample. Otherwise, if you don't do that survey launch, you may go through your entire sample with the problem that it is then too late to fix. So soft launches are always incredibly helpful in any type of survey research. All right. I will end with saying if you would like a consultation on a survey that you're considering, you're welcome to make a consultation request through Advanced CTR. That will come to me or a member of Squad, depending on the topic of your request. We're always happy to help as much as we can. And I will try to answer questions in the few remaining minutes. But for those of you who need to go, thank you, and feel free to reach out if you have questions. Let's see. I'll answer Catherine. Any suggestions for combating participants accidentally skipping a question? If you're doing that on an online survey, you can always use the request a response feature. If you don't want to have a prefer not to answer, or because we always say in consent forms, you have a right to refuse any question you don't want to answer. The other option is to put a prefer not to respond request for every question. Our practice in Squad is to usually recommend that you just use you've missed a question, you intentionally want to skip that or not, and do that for every block of questions rather than every individual question. When inattentive responses are detected, this is via intention checks. What's the protocol for handling responses provided before and after the detection point? Yeah, that's a good question. I would say that attention checks, I would not say that just if you're going to put the intention checks, only use that as a way of making a decision about the quality of the questionnaire. I would also use things like how long it took to complete, how much other nonsensical information you got. I would say the intention checks is one more tool in your toolbox to try to catch these lazy humans or non-humans. All right, any advice on completing the cherries? Should this be if you're doing surveys? Yes, the cherries checklist, excellent. Do it as part of your survey design. Can you use AI tools for questionnaires? Yes, be careful. There's a lot of, AI is only as good as the data that goes in it. Be careful about the references that AI gives you. There are many times where the AI will say, oh, this comes from the Clark et al. Questionnaire about blah, 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 blah. And that questionnaire is either non-existent or not the questionnaire that AI references. So be very cautious. I do think that AI can be used to help particularly simplify the wording of questions that you're writing from scratch. But be very careful about assuming that the references and the questions that AI suggests come from legitimate sources if you're trying to compare to other studies. What's the recommended number of items on a questionnaire to ensure? Yeah, so what's the length of the questionnaires? That really depends upon the mode. You could certainly have longer questionnaires for interviewer types of studies. Right now, online questionnaires need to be able to be done in about maximum 8 to 10 minutes. That's usually no more than about 25 questions. For surveys of health professionals, because those response rates are so poor right now, that's about 1,000 to 1,500 words. All right, Amy, I think we've come to the hour. I don't want people to feel like they have to stay. So anything else to conclude, Amy?
That's it. Just want to say thank you to everyone for joining us. And the recording of this will be on our YouTube channel in the next week or so. And like Melissa said, if you need more specific help, feel free to reach out to Advanced RI-CTR, and we can set you up with a service consult with Melissa or someone else from Squad.